So chapter 10 would cover about the structure, naming or nomenclature, physical property, which is due to the structure based on the polarity, based on intermolecular forces, and synthesis of the alcohols. Chapter 11, or next chapter, it covers reactions of alcohols. Chapter 11 is covered in organic 2. So for this chapter, going to look at the structure of the alcohol. If you take the water molecule with 2 pairs of unshared electron, it's polar. It has H bonding. Now, going from water molecule to alcohol, basically one of the hydrogens are replaced by the R group. So you have OH attached to the alkyl group, or alkane is missing one hydrogen, or one of the hydrogen from alkane is replaced by the OH group. Still is polar. And because of the OH that you have here, because of the OH group, it does have hydrogen bonding, H bonding. And how does H bonding is going to affect the physical property of the alcohol? It's going to have unusually high boiling point compared to alkane, alkene, and alkyne, because hydrogen bonding is a strong intermolecular forces. As a result, is going to have higher boiling point, higher melting point for alcohols. The hybridization is a sp3 hybrid. So these structures are here showing the bond angle compared to water is greater or closer to sp3 hybrid. That's because of the bulkiness of the CH3 or the alkyl group compared to water. The sp3 hybrid, because we have a sp3 hybrid here, is going to expect 109.5 degree, but the pair of unshared electrons that you have, the 2 pairs of unshared electrons that you have on the oxygen, they're pushing the bonds down and closes this bond angle. But when it comes to alcohol, because of the bulkiness of the alkyl group, it's repelled or is kind of trying to space out, and it opens this bond angle to 109. The OH group, replacing one hydrogen from alkane. If the OH group is attached to primary carbon, what is primary carbon? Primary carbon is a carbon that is attached to only one other carbon. So this is the bond, carbon-carbon bond. A secondary carbon is a carbon that is attached to 2 other carbons. So we have a primary, this is a secondary. Now, if the carbon is primary, the alcohol is primary. Carbon is secondary, the alcohol OH attached to secondary carbon is going to make it secondary alcohol. And then a tertiary, you have 3 carbon-carbon bond. So this carbon is tertiary, OH is attached to tertiary carbon is going to be tertiary. You have a cyclic alcohol, like this OH here, this is going to be secondary. But if you have a cyclic system attached to alcohol, this might look secondary, but it's not secondary because you only have 1 carbon-carbon bond here. Okay, so this is a primary, but this one is secondary because you have 2 carbon-carbon bond here. So it's a secondary alcohol. This is a primary alcohol. To name alcohols, you have to find the longest carbon chain. You want to make sure that the long carbon chain includes the OH group. Okay, and you have to number it from the side that is closer to the OH group. So you have to give the location to all branches, any carbon that doesn't take a number, and you have to give location to the OH also. So if we say OH is attached to carbon number 1 and you have 3 carbon, is going to be 1 propanol. Basically, you would write propane, drop the E, and add OL. So you give the location for 1 propanol. It means that OH is attached to carbon 1. 2 butanol, so means that you have 4 carbon. The carbon chain has 4 carbon. Butane, we drop the E, add OL. Butane, butanol, and OH is attached to carbon number 2. In this case, regardless of which carbon you start with, you would have 3 carbon, 1, 2, 3. So you have OH is attached to carbon 2. Also, a methyl group is attached to carbon 2. So it's going to be 2-methyl, 2-propanol. Now, which one is secondary alcohol? Which one is secondary alcohol?
Would it be the butanol? 2-butanol?
2-butanol, yes. 2-butanol, because this carbon is secondary carbon. And because carbon is a secondary carbon is attached to 2 other carbon, is going to be secondary. And which one is tertiary?
2-methyl,
2-methyl, 2-propanol. Very good. So this is a tertiary alcohol. Okay. If you have more than 1 functional group, then you have to look at which one is the high priority. So far, alcohol has the highest priority over alkane, alkyl halide, alkene, and alkyne. So for organic 1, OH has the highest priority. So you have to number, even though if you number from here, alkene would be on carbon 1, but since the priority is on OH, you have to number from right to left in order for OH to get the lowest possible number. So you would name this as the 2-pentanol, or 4-in. You have to add the 4-in. So when you have more than 1 functional group, you have to show the location for both functional group. So you have the 4-in, 2-ol. So 4-in, 2-ol. That's the carbon 4 starts with the alkene functional group, and the OH is on carbon number 2. And the total number of carbon is 5. So it's pent 4-in, 2-ol. Okay. I said so far OH is the highest, and you would need this, like starting with organic 2, you do need all of this. So you learn about alcohols. We know about the alcohols: alkene, alkyne, alkane, and then halides. Others, as you learn, you have to add to your list. So the ranking of the alcohol is higher than alkyne and alkenes and alkane halides. So you have to always make sure that it goes with the highest priority. Now, if alcohol is facing anything higher, like carboxylic acid or ester or aldehyde, then alcohol becomes branch. So in this example, we have a carboxylic acid. So obviously, because carboxylic acid has the highest priority of all functional groups in organic chemistry, then we would start from numbering as the carbon 1 for carboxylic acid functional group, and carbon 4 is going to carry the OH. So you name this as a branch. OH group as a branch is named as a hydroxy. So 4-hydroxy butanoic acid. I mean, for that, you have to know how to name acids, but we just try to at least know the order or the ranking order. If you have 2 OH group, is going to be diol. You have to give the location for both of them. Diols are sometimes they are also used as the if it's a 1,2 diol or adjacent, they are known also as a glycol. So glycols, those are 1,2 diols. So if you have glycols, it would be like 1,2 diols or vicinal diols. Ethylene glycol, that's the same thing as the antifreeze that they are using. Ethane 1,2 diol or ethylene glycol. That's the antifreeze that is used in the car because it has high boiling point and it prevents from boiling. Diols, because they have 2 OH group, more chance for hydrogen bonding. As a result, is going to be higher boiling point. If you have the diol in a part of cyclic system, and if it does show the 3D structure, then you have to say if it's cis or if it's trans. You have 1, 2, 3, 4 carbon here, okay, 4 carbon, and then here you have 6 carbon. Usually when you have open chain and a cyclic system, the priority goes with the number of carbons that you have. But since the cyclic system has no functional group and open chain has OH, the open chain takes the priority. And you have to number it in a way that OHs would take lowest possible number. So you have to start with this carbon as carbon 1, 2, 3, and 4. So we know that as our main carbon chain is a butane, but it has 2 OH groups. One is on carbon 1, one is on carbon 3. So you have butane 1,3-diol. Also, there is a branch of cyclohexyl that is attached to carbon number 1. So it's 1 cyclohexyl butane 1,3-diol. Propane 1,2-diol. So just instead of like a propanol, you would now use the diol because you have 2. Common name is like alkyl alcohol. So if you didn't have this OH here, and you were just naming this as a branch, it would be isobutyl. So with the OH is going to be isobutyl alcohol or sec-butyl alcohol. So if you know the name of the branches or name of the alkyl groups, you just say the name of the alkyl group and say alcohol. Aromatic ring or aromatic alcohols when you have a benzene ring plus DOH is called phenol. And when you say phenol, that means OH is attached to benzene ring. The carbon that takes the OH is going to be carbon 1, and you always have to start numbering from the side that is going to give or assign a smaller number to the next branch if you have another. If you have no other branches, it would just be known as a phenol. Since there is another branch, it would be 1. You have to go clockwise. It would be 1, 2, 3. So it would be 3-chlorophenol. So when you say phenol, it includes the ring plus the OH. And also is understood that the carbon that carries the OH is a carbon 1. So it is the carbon 1. And this part of the molecule is known as phenol. The only thing you have to worry about is the location and the name of this branch here. So it's 4-methylphenol.
So if phenols The OH would always be the number one carbon.
Yes. Yes, the carbon that carries the OH is carbon 1. And you don't have to say one phenol because it's kind of understood that that carbon is a carbon 1 and you number the other carbon with respect to that